Good morning, friends. Welcome to goonlinetrainings.com. So, in this session, we're going to learn why is that we have to have SSAS and what is that SSAS doing something differently, which data warehouse cannot do, and what is the need for SSAS, right? So, we had a SSAS, and SSAS is an analysis tool which is going to perform lots of operations. Okay. So stores multi-dimensional aggregated data to speed up the queries and used for large data to aggregate and stores the aggregated data. Okay. Is a multi-dimensional OLAP server and data mining server. So when you understand the SSAS, it is completely analysis tool. That means data warehouse is going to, so let me open Paint. So we know that we had a OLTP and where we're able to get the data from OLTP and we're able to load the data into the data warehousing. This is your data warehouse, right? Data warehouse means centralized hub and using a data warehouse. Now, what we are doing, we are planning to have the data into your cube and where you're able to create your cube and you should be able to analyze your data and whatever the data you have analyzed, that data you have to give it to the reporting. So let me take, this is your, could be your report. So this is SSRS report. Let me take. Now, how you're able to get the data to the SSRS report, we already discussed. If you have large amount of data from OLTP applications to the data will come. So from OLTP, the data is loaded to this. And from the data warehouse, we are going to process the data here with the help of a cube. And after the processing of the data, the same data, we're going to keep it here and we are going to analyze the data. Or sometimes what is going to happen, if you have a small data, if you have a big data, then definitely this is the right way. But when you have a small data, directly you should be able to, create a reporting services applications. Okay. But sometimes what people would do is that they get the data from the cube database and they're going to keep the data here. And here what they have to use is that they have to use MDX queries. Okay. From the OLTP applications, if you wanted to get the data, you have to write normal queries only. Okay, but sometimes without cube, this is your SSAS cube we're talking about, right? So without SSAS cube, can I get the data from the data warehouse and do it? That is also fine. Sometimes you should be able to create the reports with the help of data warehouse also. Remember this. And if you want to get the data from the data warehouse, and here also we have to get the normal queries only you have to write, and you should be able to perform all the operations. But the question is that if you have the data in the OLTP application, you should be able to create a report. Or if the entire data is loaded onto data warehouse and still we are able to create reports and we are able to give the data to the end user. And after that, what we are going to do, we are able to perform the cubing processing where you do the lots of analysis, and after the analysis the data is going to go to the end user. So from SSAS you process the data and you're going to analyze the data, and from the cube you have to write MDX, multi-dimensional expression queries you have to write, and the queries with the help of the queries you should be able to create SSRS report, and this report you can give it to the end user. So now the question is that why we have to use SSAS. Okay, what kind of analysis is going to do? And what is that end user cannot wait now? What is that end user needs with the help of the, SSAS serve? So if we have any kind of a data, I go to the database and I take this, product data, this one, and I should be able to write any kind of a query, right? For example, I wanted to uh, get the sales. So I can go to the fact sales table. I should be able to write lots of queries and get the data. Okay. Fact sales, I'll go and I have data here. The sales is happening. Now, for example, I wanted to know year-wise sales. So I have to join this table. We have a sale date key, right? So let me take this as a join. So what is the next table I'm talking about? I'm talking about dim location table, dim time table, because I wanted to get, year-wise sales, year-wise sales. Okay. So that means, sale date I'm talking about here. We are going to use the second query, that is a dim time. We are going to join the fact sales table as B. Now you have to, on condition you have to use A dot, what is the sale date key, right? Because these are sale date key equals to B dot, we have a date key, because this and this is going to, execute, and we have this data. Now I need year wise. So I have a full date and everything here. So this column and this column is, mapped, and I wanted to get year wise. So from the second table, you can take year number. Okay. That will be year wise. So you need not apply date part function and all. This is the beauty when you use this kind of things, year wise. And I want to know sales amount and sales quantity. So what is the query? Sum of sales amount as total sales. Okay. And I wanted to get what is the total sales quantity. So you have to use sum of, quantity sold, right? So that is the thing. Quantity sold as total quantity sold. And whenever you have this, so apart from aggregate functions, whatever you have, this has to be there in the group by clause. So when you execute the query, this query will say because year number is not there in the group by clause. So you have to take this and you have to go group by, and we are able to perform this and execute. Now, when you see, I am able to get year-wise the total amount and the total quantity sold. I can write these kind of queries. I can do any kind of an analysis. For example, I wanted to do year-wise, location-wise. Location-wise means I have to use one more table. The table is known as, so we have the fact sales table. Here we have location, but I need the year name. So immediately you have to join third table. So join what is the table? So dim location table. Okay, as C, and we have to say on A dot location ID, location key, and C dot location key. This you have to join, and I wanted to have year wise, country wise. So you have to include this column, country, and the same column also you have to include in the group by clause. So using the data warehouse. Okay, so now 2012, 2013 data. So year wise, country wise, what is the total sales? Or I need year wise, country wise. I wanted to have state wise also. You have to put state here. That's it. Because already you have put the state wise. Now the same state you have to keep it here also. Okay, so I wanted to have India, Karnataka, US, Texas, India, Karnataka, and like this India. So in 2013, India, Tamil Nadu, this is a sales. In 2012, India, Karnataka, this is a sales. Like that we have, 2014, US, Maryland, this is a sales and total. products they have. So you can write any kind of a query in this model also. So there is no issue. You can have year-wise, country-wise, state-wise, but only thing is that you have to make use of all these joins. And tomorrow I wanted to have what is the total, sales happened country wise, probably year wise, location wise, product category wise. So if I need a product category wise, so which products have been sold, so definitely I wanted to take entire category. So I have to include this, or I have to write one more query and taking the second requirement. So category wise, year wise, the product sold, or category wise, year wise, only the sales for the Lenovo laptops. So like that, you can ask any kind of a question using a data warehouse. You should be able to write the own logic and you should be able to get the data. So data warehouse is a database. So all the, all stored procedures, triggers, everything you can write. But normally, people will not write the triggers and all because triggers are heavy. So stored procedures, yes, queries, yes, views, yes. So data warehouse means just nothing but a database only. So you can have each and everything here. So however you're getting the data from the OLTP application, you should be able to get the data from the OLAP application also, because the product data, this data only we're able to get here. If the sales table is having this kind of a numbers, and he should also get the same kind of a number is here. And tomorrow, if the numbers are not matching with the OLTP queries, and definitely the people would ask the same query if you wanted to write, and you can write in the database or in the OLTP database also. But ONTP, you have to use, you have to use product master and sale date. We have to use, date part functions and all, and you should be able to write in the OLTP as well. But you have to understand OLTP numbers and these total quantities should match. If something is not matching tomorrow, then they will tell you why the data is not matching here. You have to rectify the error. So then you have to see whether all the packages have run, what is the total number of rows we have, and where the data is not running. So you have to, try probably run packages. If one of the packages failed or did not run, or if there is an error in one row, it is not going to the data warehouse, then you will get mismatch here and there. So whenever you load the data from OLTP to data warehouse, randomly they do the regression testing. Regression testing means whether everything is loaded, the totals are coming properly here. So same query they execute here. The same query means the tables are different. That they'll write different query here. So when they go to the OLTP database, they can write same kind of a query here also, but they don't get the state-wise, country-wise, because state and country is not there in the OLTP. And but they definitely they can have year number, year-wise, so city-wise they can have. So some kind of a things they can do it. So total sales they can have, and they should be able to do it. But even though we are able to analyze the data with the writing queries, the question is that why still we have to go to the cube and why we have to do the aggregations and all. Let us understand. Now, let us understand all the data we have given to the data warehouse. Now, the data warehouse is the centralized data. Okay. Now, I'll give you one simple example. I think I would have given this example, right? The if somebody is supplying a milk or water to you, so you're storing date column you have and the quantity supplied. Okay, and you're writing on this. For example, in India, normally what we're going to have is that we have a milkman and they're going to supply the milk. So day one, I have taken 2 liters of milk. Okay. And day two, I have taken, say, 4 liters of milk. And day three, I have taken, say, 1 liters of milk. So something like this. I'm writing my data whenever they're supplying the milk, and this is my dairy. Okay. In my notebook, I'm writing. So this is for example, say August 2016, the milk supplied to me. So this is the data. So I am putting it, and like that I'm writing. And at day four, uh, August, date 4, That fellow was absent. We did not get the milk and all. And I was also maintaining one more column, that is the the quality of the milk, whether the milk is good or bad. So I am also writing in my notebook. So they have supplied, but the milk is very good. So they supplied 4 liter of milk. The milk was bad. So it is not this, and they supplied milk was good. Okay, so fourth day he was absent, right? And I maintain one more column, whether is the milkman who's going to supply is on time or not. Okay. So in this day, he was on time. Yes. So here he was on time. Okay. Like that, I'm storing some data. And here the milkman was not on time, but milk was good. So here the milkman was absent. Like that, I'm storing some data. Very simple, notebook. I'm storing the data. So end of the month. So 30th, and also say he has supplied 1 liter of milk, and milk was good and he was on time, like that. And 31st of August he supplied 2 liter of milk, and the milk was quite bad, and came on time. So that's it. I maintain. So the month is over. The end of the month, the milkman is going to come and ask, sir, we need the amount. So can you pay the amount today? Because end of the month we're supposed to pay the whatever they supply. So what is that I have to do when they apply, when they ask for the money? So I have to total all this, liters. So 2 liter, 2 plus 4, 6, and 6 plus 1, 7, and 7 plus 1, 8. So like that, I have to do complete, totals. I have to perform an aggregations I'm talking about. Okay. I have to perform aggregation. So think, so the total liters I have consumed in last month, in August month, probably say some 44 and off. Okay. And each into, so we are talking about into, the each liter could be a 77 bucks I have to pay. Okay, so now I have to perform this calculation, and I'll get some amount, and that amount, for example, say some some X amount you're going to get, or some A amount you're going to get, that amount I'm going to pay. So when the milkman asking, pay the amount, sir, and I'm saying, I did not calculate. Can you please wait? I'm going to do all these things, and I'll tell you, I have taken this notebook, and I'm doing aggregations. I'm doing totals. Then the milkman comes, sir, I don't have time today. I'll come tomorrow, sir. Please make it ready so that you can pay me the amount without any delay. Now I got a shock. Why? He says that he needs money, but now he's going, but now he says he doesn't have a time. So now let us understand what is very important. I supposed to make the payment to him. He needs money, but more than the money, now he's saying, I don't have time, sir. I cannot wait here. Please do the aggregations, totals and everything. Keep the total ready. And tomorrow, as soon as I come, and give me the amount. So now you have to understand, it is not the amount he needs. He doesn't have time to stay back because you're performing aggregation, and you're saying 2 plus 4 plus 1 plus blah, 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 and you're going to do the calculations. Now you're doing the calculations, but suddenly you got a phone call, and you closed the book and went away. Okay. You have calculated and everything is fine. You got some amount, say some 4,123 you're supposed to pay. Okay. So that we have calculated and everything is fine. But only thing is that the total you did not write on the book. So, you got some phone call and you did not write anything on the book, and you forgot. Yesterday, tomorrow, the milkman again comes and he'll ask you, sir, can you make the payment? Because today is 2nd or 3rd of the September, I need the money. So you open the book and you shocked. You thought that you have done all aggregations, and the aggregations are ready. Only by seeing the amount you should be able to make the payment. But unfortunately, you have aggregated the data, but one thing you missed, you did not store the aggregations. Now again you say, I'm so sorry, I have calculated yesterday, But only thing is that I did not store the totals because this is history. Because last month data, nobody will make changes here. Try to understand. So you can make aggregations and keep it ready. Try to understand. So all the historical data in the data warehouse will be there. And at the time, when you take some time and you have to aggregate the data and you have to keep it ready. The milkman again says, sir, I'm so sorry. I cannot wait today also because I have to supply the milk to so many customers in the city. So please make the aggregations ready by tomorrow, sir. I need the money. So now you're saying that again you do the aggregations and each liter cost you this much and total amount, for example, you have to pay this much amount. You have aggregated this and tomorrow the milkman comes and you're opening the book and you're paying 4123. Now tell me, in this example, what is that the data warehouse is going to contain? What is that the cube is going to contain? So the data warehouse contain detailed data. So this is the data you're going to have in the data warehouse, and the totals and aggregations are done and created and stored in the cube. So what is cube is going to do? Cube is going to do complete totals and aggregations, and it will perform total and it will store this total. Okay, so it will perform total because when you have this kind of a measures, on the measures it will get the totals and it is going to store this total. So what is the total here? 4123, and this is the total I have to pay for August 2016. Okay, like that it is going to store. So what is this data? Where is this data stored? This data is available in the data warehouse. So data warehouse contains raw data. Try to understand. Data warehouse contains raw data. Cube contains aggregated data. So that means you're going to perform lots of aggregations here and you're going to store. So when you have a raw data here, so what is the problem? The problem is when you open any kind of a report and when you're trying to take any data from here, so in our example, what is going to happen? You have to do the aggregations on the fly. Aggregations on the fly, we have only 31 days data. Now you're able to do the aggregations very quickly and you say that it is 4,000. But think you have 10 million data, 20 million data, and the customer is opening a report here, and whatever the query you have written inside the report, it is going to go to the data warehouse. And think about this query only. And since I have very little data, this query able to give me the report or this output very quickly. But think about, I have 10 million data or I have 100 million data. Think about, I have 1,000 million data. When you have 1,000 million data, when you run the same query, do you think that the SQL Server or Oracle is going to give you the answer however it is giving? So now it is able to give you just like that, because I have approximately some, very few rows. I have approximately, I have 1,000 plus rows or I have 100 plus rows. Now, the same query which you have written here, this is not going to work when you have huge data, because when you're joining the fact sales table with the dimensional tables and do all these aggregations, because aggregations will take a lot of time and you have to apply the group by clause, definitely this report will become very, very slow. So however, milkman was waiting yesterday, and the report people have to wait for the aggregations to happen. Then you will say the totals is this. But definitely what is going to happen when you take the data from the data warehouse and create your own queries, and when you run the report, definitely report will become very, very slow. Okay, so instead of taking the same data, the aggregated, for example, I have 10 here, I have 10 and I have 20 and I have 30 here. Okay, this is the raw data I'm talking about. And the cube is going to store the total. The total is, let us say, 60. And if you need the total, you can go to the you can write data warehouse and you can sum this and you can print, or you can go to the data SSAS cube and you can get the 60 and you should be able to print. But definitely when you go to the data, instead of going to the data warehouse, you better go to the cube, and the cube is already would have processed the data, the aggregations would have been done and it would have given to you. So when you have a large amount of data, definitely cube is going to give you lots of, or time it's going to save. That is what you have to understand. Now think about in this example, we're talking about only one aggregation, that is total. But think about tomorrow. I wanted to understand what is the August sales and what is the September sales. What is the year-wise sales? What is the month-wise sales? What is the sales in US? What is the sales in UK? What is the sales in Lux? What is the sales for Lux in Europe? What is the sales for month-wise, year-wise, semester-wise, that-wise, this-wise? So we are not talking about only one aggregation. We are talking about multiple aggregations, multi-dimensional. Multi-dimensional means I need year-wise, a dim time table we're talking about. I need country-wise, location-wise, state-wise, month-wise. So we're talking about lots and lots of aggregations, and all aggregations, when you're, asking you to do here, definitely you will take time. For example, tomorrow Lata comes and asks me, Bhaskar, tell me how many times the milk was bad and but the milkman was on time. Can you give me a report, Bhaskar, for only August month? The query, let us understand. The quality was bad, but he was on time. And how many times it has happened? I need a report. She is my manager. She is going to ask me. Now, I'm going to go here and I'm going to get. But she is going to ask, last 5 years, I wanted to know how many times the milk was bad, but he was on time. Or I wanted to know how many times he was absent for the last 1 year, last 1 quarter. I need year-wise, semester-wise, quarter-wise, month-wise, how many times he was absent. I wanted to know how many times the milk was completely bad. How many times I want, I wanted to know he was not on time, so, but milk was good. So like that, you can ask thousands of questions. But now here, we are talking about only 1 month data. We are able to do some kind of an aggregations, and you have to think about logic also. What logic you have to write? That logic also you have to scratch your head. But tomorrow, when you give this kind of a data to the data warehouse, all permutations and combinations, try to understand what is that, how many times milk was good but milkman was late, how many times milkman was late and milk also bad, and I need year wise the count, I need month wise, semester wise, like that. All permutations and combinations it's going to give you without writing a not even single query like this. Now, what is the advantage? You need not scratch your head to write the queries. You give the data, all permutations and combinations, aggregations are done with the help of cube algorithms and with the help of a cube, you know, uh, modeling elements. End of the day, you just take the data and dump it here. So tomorrow the customer is going to ask, and what is the sales happened in the August? You have to just go and write appropriate query, and you're going to do. Now when you open the query, the already aggregated data, because when you open the query, when you open the report is very fast because already aggregated numbers are stored here. You say the last 1 year the milkman was absent 24 times, and last 5 years the milkman absent was could say 233 times. So the aggregation is also done. You're not going to do anything here, so everything on the fly is going to write. So if the cube is not there, you have to write what is the logic. I have to write as a developer, you have to scratch your head. The second thing is that if the data is too much of data, 100 millions of the data, and the entire logic has to run, the report will become very, very slow. Try to understand. Okay, two things we're going to understand, because you're not talking about any logic here. The entire logic, the cube is going to analyze your data or create lots of aggregations, and all permutations and the combinations it's going to use from the dimensional tables and factor tables, and it is going to perform all aggregations, and only you have to go to the report, and report is going to get the data, aggregated data. It is going to give all the totals here. And but whenever you go to the data warehouse, you have to think about a logic like this, and you have to run this query on the fly. And if you have millions of data, this query will not run at all. So this query, the SSRS report is going to tell you timed out error and there is no time latency issues, the end user will say, however, milkman was saying you are aggregating the data and the milkman was the end user is not going to wait. The customer also tomorrow says, hey Bhaskar, your application is very, very bad because whenever I ask a report, you are saying that you are aggregating the data and the getting the data. Can't you aggregate and keep it somewhere so that whenever I ask a question, you will be able to give me report because the data warehouse means history, historical data. Nobody is going to update the data. Nobody is going to modify the data. What is the problem when you aggregate the data, when you keep it there ready? Okay. So data warehouse is going to store raw data and the cube is going to make aggregated data. Think like this. This is why we have to do. So if somebody is asking why we have to go for the cube, okay. So why cube means you have to tell them that cube is going to make, okay. So super slow BI application will become super fast BI application. That's it. So if somebody asking why we have to use a cube, if cube is not there, what is going to happen? Very simple. You have to think about a logic and all the logic whenever I'm opening the report, that time what is going to happen is that the query will get executed, is going to get the data from the data warehouse. Now end user say, I don't have that much of time. I cannot wait. I have to click on a report, get the totals. That's it. If you tell me this kind of an approach, then I'm able to listen. I'll be listening to you. Otherwise, don't tell me that, sir, this report is getting executed. Why it is slow? Then you are telling that, sir, we have so much of data in the data warehouse because of that, queries. But all these stories, the end user is not going to listen to you. Clear? So now there is a simple question. Let me ask. For example, you have some food, chicken is there, raw chicken is there, and why are you cooking the chicken and making ready for your husband or for your kids? For example, your husband also knows how to cook, right? You think about, you have a chicken here, or you think about, you have some food here, and whenever we go to the home, the cooked food is ready. And if the cooked food is not ready, and I know that I know how to cook the food, so I can take the chicken or rice and whatever you have, I should be able to take the raw data and I should be able to cook and I'm able to eat, right? But when you have a raw rice, and why are we not keeping the raw rice and why are we not saying that you take the raw rice and you cook and you eat? That is also fine because I know cooking. But the problem is that whenever the husband or the wife or mother comes to you home, when you have a raw rice, so that first is that they have to know how to cook rice first. That is logic. Second thing is that the cooking will take 20 minutes of time, 30 minutes of time. They have to wait. Then only they can start eating it. So if you don't have the time, so you have only half an hour time and you have to come home, take the raw data and you have to process the data and then you have to see the report. That means you have a raw data, you have aggregated data. You have a raw food, you have a cooked food. Now tell me, when you have a raw food, you can tell them that you cook and you eat. Why is that I have to cook? Then definitely there is a different behavior. When you have a raw food and you are not cooking, the people who are going to need, they have to know how to write the logic, how to cook the food. That is one pain for them. Second one is that they have to wait for 20, 30 minutes to cook. And third one, they can eat. So when you take a data from the data warehouse, so that is it is a raw material. So raw rice, raw wheat and raw meat and raw chicken. Okay. So the cube is a cooked food. Cooked food means all combinations, not only one. For example, if I have a data warehouse, I have to know only one item I can prepare with the chicken. But if I give this to the cube, cube will make, for example, I supply lots of, curd and I supply rice, I supply, lots of things, all permutations and combinations of the chicken varieties, it is going to give you with the chicken, with the dal, with, the curd, with, whatever you supply, raw material. Based on the raw material, it is not going to prepare only one chicken item. Try to understand all combinations. Okay, it may prepare chili chicken, it may prepare some Taiwan chicken or Indian style chicken based on the raw material which you apply, which you supply to the cube. So think like a cube is a chef. It's going to process, and the data warehouse is just like your storeroom. Think like this. Okay. So you consume the raw material from the data warehouse, from the storeroom or the godown, and we have a chef, the SSAS. It is going to take all the material, all combinations is going to make, and all varieties of food is going to put, and that cooked food you can consume as an end user. So when you go to the dinner or lunch, the food is cooked already. You just take it and eat it. So definitely, when you have a chef at home, and definitely you're going to get. If the chef is not available, also you should be able to cook the food and get the food. But if the chef is not there, you have to waste your time. And when the crowd is more, when the people are more, you have to prepare the lunch or dinner for 10,000 people. Then definitely you cannot take the raw food at the time of the customers are visiting your place, and that time you started cooking. So definitely it's not going to happen. So all the end users, they wanted to see that the reports and different varieties of reports they wanted to see. And that time when you say, let me write the logic and let me execute the logic which I have written, then it is not going to work. Clear? So try to understand, data warehouse is going to have a raw material, and SSAS cube is going to have a cooked food. And people may ask you, I have a raw material, I have a raw data like this. I should be able to write this logic and get the data, but why I'm not doing this? Only simple. So on the fly, you have to cook, and you have to know how to write the logic. And even for the developer also, it is very difficult. And when I write the logic and run on the query, and because of large amount of data, the query will be slow. That's it. So when you understand these points, this you should be able to clearly tell them. So if somebody asks you why cube is going to make very simple. It is going to keep the aggregated data here. Because of the aggregations, your reports are faster. That's it. Okay. But when you have small data, then definitely you need not have SSAS at all, because when you have only one guy, two guys are there, and you need not worry about food because you should be able to cook. So within 20 minutes or 1 minute. But when you have large amount of data, then you have to worry here. So normal queries means on the fly it is going to work, and this is fine. When in the data warehouse also, sometimes you have little data in some tables, and you should be able to write like this. But when you have large amount of data, you have to write. So it is not going to analyze as it name says. So SSAS is not going to analyze anything. End of the day, the end user is going to analyze the data in the reports. But why are we saying analysis survey? Because all permutations and combinations of the sales will be given. So with the help of that, you can easily and quickly you can analyze the data. Why the sales is down here? Why the sales is up here? Why the India sales is not at all happening in the last 3 months? So all these things we should be able to analyze with the help of the aggregated data. As soon as you open the report, the entire aggregation, the totals can be dumped in this. But remember, however you are processing the food, the chef is also going to process the same way. And when you wanted to cook rice, or if you wanted to make a pizza or a chicken, if you need 1 hour of time, and chef is also going to take 1 hour of time only. Remember this. And the cube also needs a lot of time to process the data. When you have a large amount of data, and the cube sometimes takes 1 day, 2 day, 3 day, and 10 hours, 5 hours, 2 hours like that, it is also going to take lots of time. For example, when you dump 1 terabyte of data to the data warehouse, then you have to start processing the cube. When you start processing the cube may take 4 hours or 1 hour or 2 hours to perform all aggregations. And after that only, you can start delivering the report. So if the ETL is taking 4 hours, and after 4 hours, you have to give at least some 2 to 3 hours for the cube, and the total is 4 plus 2, 6 hours. And seventh hour, or after 6 hours only, you should be able to use the reports to the end users. So this kind of a latency or delay you have to expect. Okay, so this is what you have to understand, why we have to create a data warehouse. And even though data warehouse is there, why we have to create a cube. When you create a cube, all aggregations are happening. So when you drag and drop the aggregations here, the SSRS report is not going to aggregate any data on the fly. It is simply take the 60 and it's going to display because aggregated already. But if you take a data warehouse and OLTP, It is going to take the query and it is going to aggregate the data and it's going to give you. So it may take slow. It may be slow. So OLTP data warehouse of applications can also be used to create your BI applications, because end of the day, end user needs a report. He does not know what is a data warehouse, what is a cube and all. He will not be able to understand. End of the day, the report is the BI application for him. And the BI applications can be made without data warehouse and without cube, or BI applications can be made with the help of data warehouse and cube. Large data warehouse, cube is needed. Small data, BI applications can be made with the help of OLTP only. Are you clear? So this is what is that. So is an analysis tool, stores multi-dimensional aggregated data to speed up the queries. Try to understand why it can speed up, because it has done the aggregations. Used for large data to aggregate and store the aggregated data is a multi-dimensional OLAP server and data mining server. What is the data mining is out of scope, but I'll give you some of some examples very soon. And it is going to play two roles. One is OLAP to store the pre-aggregated values and for the multi-dimensional analysis. And in the pre-aggregated values, you can understand, the how the past, what is the sales for quarter one, quarter two. And data mining is, for understand the trends and patterns of the business. And it is going to give you some kind of a predictions. For example, I wanted to know and what is the sales may have. For example, I'll give you one query. If all employees are getting 20% hike in this year, and how many people may buy two-wheeler, and how many people may buy four-wheeler. So this is a prediction. For example, your salary is current salary is 80,000 rupees, everybody is getting, or 40,000, everybody is getting, and the hike is 20% or 30% or the 40%, whatever it is. If the hike is 40%, how many people may go for four-wheeler? How many people may go for two-wheeler? For example, Samsung is creating a mobile phone. iPhone is creating, Apple iPhone is going to be released. The cost would be, let us say, in Indian currency, 25,000. So Apple people are, saying, if I reduce the price for 5,000 rupees in Indian market, how many more people are going to buy my iPhone so that I can, catch the revenues? Whether it is 25,000 rupees, 10,000 people are buying, and with the 20,000 rupees, 1 lakh people are buying, definitely I'll get the same profit, but people will say it is cheaper and it is inexpensive and good. So that is a prediction. So predictions means this kind of things they have to think about it on the data. So okay, data mining is also part of data warehouse. When you have a data raw data, then you can do lots of things on this. So predictions can be done on the data, and this kind of things also we're going to do, but it is out of scope for us. And we are going to analyze what is the sales happened in the last one, quarter one, quarter two, and year, month wise. This is what is called multi-dimensional data. You can understand the past, but you should be able to understand the future also. Predictions also you should be able to do it. Okay. Now, need for SSAS. SSAS makes super slow BI application as super fast BI application by using pre-aggregated totals for multi-dimensional analysis, as we discussed. Because when you take a raw material and when you prepare a dish and keep it ready on the dining table, and the end user is going to come and he can easily take the food without having any delay. Now, when you have a small data, OLTP and reporting is done. But when you have a large amount of data, you take OLTP and you take OLAP. OLAP means we're talking about data warehouse, and you dump the data to the cube, then you create a BI application. So hence SSAS is not a mandatory component to develop BI applications. So many people, I'm also using BI, but I don't have cube and data warehouse. We are using only OLTP and creating a report. That is also fine, because they have little data, so you can just come home and prepare the food and eat. That is not a big deal. But when you have a large amount of people are going to visit your place, then definitely you have to worry about it. Okay, so remember what is going, cube is going to help you. Cube is going to make the aggregated data. Because of that, RSS RS reports are very, very faster, very, very faster. I'll give you one more real-time case study we had faced. Okay, now, so we were talking about we had one small company in India, and they were having a client server architecture. All the data they were storing in PHP. This is the front end application. With the front end application, they were developing and putting all the data into a database, and this is their OLTP, and they were using MySQL. Okay, MySQL, they were able to store the data here. The business was started in 1996, and PHP, they were using front-end application, and it is a medical application for one small hospital. They were using this. So whenever you go to the hospital, the doctor data, payment data, lab data, all of them they're able to capture in this, and they were happy. And the number of sales was very little, 100 per month and 200 rows per month. But after 10 years in 2006, they had increased the revenue. But 2006 to 2016, what has happened? That drastically this has happened. So from millions of turnover, they have reached now very big amount, billions and trillions they have reached. Now what is happening? So when keep all the data in the MySQL is not at all giving them any kind of a report in the PHP. In the PHP, you can go to the login page, you can register as a patient, or when you go to the hospital and they're going to register, and in the PHP only they have created some reports also. Okay, so for the end user, they will not be able to open the reports, but the management people, they're able to open the reports. But 10 years back, the reports were opening very quickly and nicely because less data. But drastically the data got increased today. What they were doing is that they were taking the backup of the MySQL database, they are keeping in the hard disks. But unfortunately, if they wanted to do any analysis now, whatever the data they are keeping in MySQL, last 1 year data, last 2 years data, but remaining data, they cannot keep it in MySQL, right? So they have archived it. But if they need the analysis, they are not able to do. And last 1 year data also huge data for them because of the growth in the business. So the MySQL is not able to capture the last 2 years data, last 3 years data, and they're able to whenever they open the report, the reports are very, very slow. So what is they should do? That is the question. Then we told them that you take all the historical data, all this data with the help of ETL. You perform one ETL, SSIS or something. You put it here. You dump all this data. So when you have backup and archive files also, you give it to us. So we are going to dump all this data to the data warehouse. So you have to buy one more server, and the server could be your database server. You're going to keep all of them here, right? So once you keep all these things are in the data warehouse server, and from this server you have to do the analysis and everything here. That's it. So using that, what we are going to do, we are going to create lots of reports. So this is my report, and not only one report, you can make a couple of reports here. All these reports we are going to make now. These reports are getting data from the data warehouse, and old data, historical data, you're going to dump for last 20 years, 1996 to till probably 2015 or 2014 data will be in the data warehouse, and all the reports are made. And these reports, what we are trying to do, all these reports we are going to connect to the front end application. That's it. So when you open the report, the sales is happened in 2013, and the last 5 years, last 2 years sales, all the reports we are creating it here, and all of them we are going to dump into PHP itself. So PHP is able to get all my reports, but the original data from the front end application is going to be dumped into MySQL, and from here we exporting the data to SSIS to data warehouse, and in between you will have staging database also. Remember that. And you're going to clean the data, you create dimension table, factor table, you're going to analyze the data. The reports are now very, very fast for the business. Now people are very happy. We did not disturb anything to the front end application. OLTP is running PHP with MySQL only. So only we have introduced the data warehousing application to that business. Now it is happening like that. So once in a 6 months or once in a month, the SSAS pack is going to take all this, the last month data, last quarter data, they're going to dump into the data warehouse, and we are going to, put all this data here, and we are going to create a data warehouse. And in between, we had also created a cube. So this is your cube. And with the help of the cube, what we are doing is that we are going to dump the data to the data warehouse. That is what the cube, sorry. So from the cube, the data will go to the SSRS report. Now cube is going to perform all these aggregations, and the cube is very, very faster in between. And this is how you should be able to analyze. So data warehouse means people definitely have to use the cube, because the cube is going to give the lots of aggregations and all. So this is how the new scenario for them. So what is now happened? They were having a problem. The reports were slow. Now, because of this, the extended architecture, the reports are faster. We did not replace PHP, we did not replace MySQL, but the aggregated data, the historical data we had taken from MySQL, and we have taken from the lots of, they have archived in the backup files. All backup files we have taken, we dumped into one staging, and from staging, we had dumped all the data to the data warehouse, and the now data warehouse is up and run, and the cube is also happening. So this is how you can understand the problem is now solved. What is the problem? The reports are slow. Now reports are very, very fast. Reports were slow. Reports are fast. Now tell me, what is that you're going to understand? So you can understand, when you have BI applications, you can analyze any kind of a data with, with, little time. So that's what you have to understand. Clear? So any questions? So tomorrow we're going to learn how to create a first SSAS cube.